Okay, today we will discuss about the statistical averages, that is the mean and the variance of a random variable. Okay, we have already defined a random variable in the continuous and then in discrete form. And in the continuous form, we have started from the CDF and then which is fx of x, and then we have defined the PDF, the probability density function of the random variable, which is px of x as the derivative of f of x. Okay. Likewise, we have also defined the joint PDF pxy of xy, which is equal to the probability of x equal to xi and y equal to xi y j. You can say xi and y j, or you can also define the joint CDF and the PDF for the continuous random variables. So the joint CDF will be fxy of x comma y, which is the probability of x having a value less or equal to x and y less or equal to y. Similarly, the joint PDF of continuous random variables will be del square by del x del y, the partial derivative of x, f of x y, x comma y. Okay, so this is the joint PDF for discrete random variable. This already we have discussed in the last class. This is the joint CDF for continuous random variable, and this is the joint PDF for continuous random variable, which is defined in terms of the derivative of the CDF, joint CDF. Okay. Likewise, you can also define the conditional probabilities for the joint random variables using the same probability rule. So if you use the base rule, we have already that pxy of xy, that is the joint PDF of x and y, that can be written in terms of the conditional probability density function, that is probability of x given y multiplied with the probability of y. Okay, or it can be written as the conditional probability of y given x multiplied with the probability of x, and so on. Okay, and likewise you can also define the independent random variables, like we have defined independent events in the probability. So if the two random variables x and y are independent, then of course the conditional probability of x given y will be simply the probability of x. Okay. Likewise, the conditional probability of y given x is the same as probability of y. So it implies that if x and y are independent random variables, then probability of xy, that is a joint PDF, can be written as px of x into py of y. So their PDF is basically separable if the two random variables they are independent. Okay, and likewise their CDF can also be separated. Okay, now we will discuss the statistical averages. Statistical averages, which are important parameters for any random variable. So one is the mean of the random variable. You can start from the discrete random variable because it is easy to define the mean for the discrete random variable, and then you can extend it to the continuous random variable. Okay, so as a example, suppose in the example of rolling a die, you have 6 possible outcomes. Okay, the number 1 to 6, any number can appear on the dice. So if you roll this dice, suppose n times, okay, and n is very large, you roll the dice n times, and suppose the number 1, it appears n1 times. Likewise, the number 2 appears n2 times, number 3 appears n3 times, and so on, and number 6 appears n6 times. Okay, so if you find the average of this random variable, average value or the mean value, which I denote with x. Okay, so if you say in the sample space, maybe if you draw its PDF, you could have 0 to, sorry, not 0 to, you will have the values from 1 to 6. So the probability of 1 will be the number of times this number appears divided by capital N. The number of times we have completed this try. Okay, so that will be n1 by n. So n1 by n will be the probability of getting 1. Okay, similarly, if the number 2 appears n2 times and we have total n tries, then n2 by n will be the probability of occurrence of number 2, and so on. Okay, so definitely they will have different probabilities in this case, because the number of times each number appears as the outcome is not same. Okay, so if you find the mean of this x bar, or we also write it as a of x, the expected value or the average value, this is called as the expected value of the random variable. So I can write it as 1 into n1 plus 2 times n2 plus 3 times n3 up to 6 times n6 divided by capital N. Okay, because your n1 times 1 appears, n2 times number 2 appears, n3 times number 3 appears, and so on. So if you find the average value, we get this. Okay, and that is simply n1 divided by n plus 2 times n2 by n plus 3 times n3 by n, and so on, 6 times n6 by n. And I already discussed that n1 by n is nothing but the relative frequency or the probability of getting number 1. n2 by n is the probability of getting output as 2, and so on. Okay, so this I can write as 1 into probability of x is equal to 1 plus 2 times probability of x is equal to 2 plus 3 times probability of random variable x getting a value of 3, so on, 6 times probability of x is equal to 6. So I can simply put in the form of a summation of, I can say, xi into probability of xi. Okay, where in this case your I will go from 1 to 6. So xi is the values which the random variable can take, and px of xi is the probability of the random variable having a value equal to xi. If you multiply the values of the random variable with their corresponding probabilities and you add it over all the possible values that the random variable can take, that will give you the mean value or the expected value of this random variable x. Okay, so in general you can define the mean of the random variable x. The mean of a random variable x can be defined as x bar or e of x equal to mean value or average value or expected value. Okay, so it can be written as summation of xi into px of xi summation over I. Okay. So I may take any number of values. Okay, like in case of rolling a dice, you have I goes from 1 to 6. If you toss a coin, suppose, then you have only two values, 1 or minus 1. Then I will go from 1 to 2 and so on. Okay, so this is how you define the mean of a random variable, discrete random variable. And likewise, if the random variable is continuous, so for continuous random variable, you can have a simple sum, you can say equation or a statement where the mean of the random variable, continuous random variable, instead of summation, you will have integration, and of course these probabilities, they are no more discrete. You have a continuous range of function of the values. So it becomes x into px of x into dx. So this is the mean value of the continuous random variable. Okay, so as an example, suppose we have defined a random variable in the last class. Okay, that you are appearing in a class test and the marks that are obtained by the students, they are mapped on the real axis. We call it as a random variable. Okay, so you have different students starting from roll number 1 and so on, maybe up to roll number 50 if you have a class of 50 students. So they are mapped. So you define a random variable x which maps each candidate with the marks that are obtained by him or her in the test or exam. Okay, and the range of marks can be anything. Maybe it is minimum is 0 and the maximum is suppose 50. So more than one student can have 0 marks, so they are mapped to 0. Likewise, if you suppose have a 20 marks, so there may be 3 students which are getting 30 marks. So all the 3 students, they are mapped to this number 20. And then we have defined its PDF x of I and probability of x of I. So 0 to 50. So suppose 2 students has obtained 0 marks out of 50 students. Then the probability of 2 is of course 2 by 50. Okay. I suppose no student has obtained 1 marks and the probability of 1 is 0. Likewise and so on. So suppose 3 students have obtained 20 marks, then the probability of 20 will be of course 3 by 50 and so on. This is the PDF of the random variable, and if I find the expected value or the mean of this random variable, then definitely this is summation of xi into px of xi. Now I in this case will go from 0 to 50. Okay, because the random variable can take any value in the range 0 to 50. It will be simply xi, so x0, which is 0 multiplied with the probability of 0, plus 1 multiplied with the probability of 1, and so on up to 50 into multiplied with probability of x is equal to 50. That will give you the mean value of this random variable. Okay, in fact that will simply give you the mean marks or the average marks. Okay, so it is the same thing what you do in you can say linear algebra, that the sum of the numbers is simply the average of a sequence of numbers is simply the sum of all divided by the total number of numbers. That is something. Okay, the only thing is that we are defining this in the terms of probability, nothing else. Okay, so when you find the mean of this random variable, that will give you the center of this density function. Okay, that will of course give you the center point of this PDF, which is the average value. Okay, the average marks which will be obtained by the students in the class. Okay, likewise we define one more important statistical parameter, which is called variance of a random variable. Or before variance, you can define the mean of a function of a random variable. Okay, the mean of a function of random variable. It means x is a random variable and you define another random variable y, which is basically a function of x. Then you have to find the mean of y or mean of g of x. So that will be simply given by the summation of g of xi into probability of xi summation over I, or for continuous case it will be the mean of this function of a random variable will be integral of -2 plus infinity g of x into p of x dx. This probability density function will remain same. Okay, so you have one random variable x and then you define another random variable y, which is basically function of x. Okay, then the mean of this random variable is simply given by this relation. Okay, because see, if you say that this random variable x suppose takes some discrete values, maybe x1, x2 up to suppose x of n, with their corresponding probabilities px of x1, px of x2 up to px of x of n, then these values x1, x2 up to x of n are simply transformed to new values y1, y2 up to y of n as per the equation that we will have this equation of this function, and the probability of y1 will be simply the probability of same as the probability of x1. Okay, similarly the probability of y2 will be same as the probability of x2, because only the values have been changed. Okay, so you have mapping from x to y, so the value which is x1 in x is now transformed to y1. Okay, definitely its PDF will remain Okay. Similarly, a value x2, which the random variable x can take, will be transformed to y2, and the probability will remain same. Okay. Same points. Suppose in the random variable x you have x1, it means the probability of this is suppose 5 by 10, 5 by 50. It means you have 50 outcomes, and out of 50 outcomes this x1 appears 5 times. Then this x1, which is 5, will be transformed to y1 according to some function. So those points which have the value of 5 will be transformed to a same point, to map to the same point in the random variable y. So that is why their PDFs will remain same, and accordingly the mean of the function of the random variable will be simply the function for a particular value of xi multiplied with the probability of xi. Okay. Like suppose one important case in this case is if I define a function as y is equal to x square. Okay. If x is a random variable and y is equal to x square, and if you find the mean of y or the expected value of y or expected value of x square, that will be now in this case the function is y, which is g of x, it is simply x square. So it is simply taking the square of the values of the random variable which x can take. So if suppose the random variable x takes a value of 1, then that is transformed to 1. If it takes value of 2, it is transformed to 4. Okay, and so on. So e of x square will be simply equal to integral of g of x, which is x square, into px of x dx. Okay. So this is an important statistical parameter again, which we call as the mean square value. Okay. This will be taken as the mean square value of the random variable x. In fact, it is called as the second moment. Okay. You can define the nth moment. You define the moments. The nth moment in general defined as e of x to the power n. Okay, and that will be integral of x to the power n into px of x into dx. So for n is equal to 2, this becomes a special case which we call as the mean square value. Okay, so for discrete case it will be simply summation of, for discrete random variables, e of x square will be simply summation of xi square into p of px of xi sum over 1. Okay, so you're basically finding the square of the values and then you're finding its mean. That is what is mean square. Okay. And another statistical and important statistical parameter that we generally used while discussing random variables is the variance. Variance of the random variable. The variance of a random variable is defined as sigma x square, which is the expected value of x minus x bar square. Okay, or I can write it as x minus x bar square whole bar. Okay, so you subtract the mean basically from the random variable. Okay, and then you find its mean square value. That is what we call as the variance, and the square root of variance is called as standard deviation. So standard deviation is simply sigma of x. Okay, like we have taken the example of the class test. So you have a random variable x and you have certain probabilities of getting the random value x having a value between maybe 0 to 50. So based on this PDF, this is px of xi. So you go to mean value or the average value. Suppose this is the mean value, which is e of x or x bar, or sometimes we also call it as mu of x, right? So once you compute the mean value of this random variable, then you can find this difference x minus x bar. Okay, so suppose you have 0 to 50, and suppose the mean value of this random variable is suppose maybe 10, then you will find x minus x bar. So you have 0 minus 10, you will get minus 10. Then of course 1 minus 10, you will get minus 9, and so on. So we have another vector, okay, which contains this difference x minus x bar or x minus mu x. So x is the values which the random variable will take, and x bar is the average or the mean value. So once you define this vector x minus its mean, then you take its square and its mean. Okay, then it is again the mean square value e of, but in the mean square value you just take e of x square. In the variance we take e of x minus x bar square. Okay, that will give you the variance of the random variable. In fact, the variance of the random variable is basically a parameter which describes about the spread of this probability density function. Okay, like if I suppose take two random variables which may have a PDF like this, and this is the mean value, which is the center of this PDF, and I take another random variable which has a PDF like this. The mean of this is also mu. Okay, both have the same average value or expected value, but you can expect that the variance of this random variable will be higher as compared to this. Okay, because the spread of this is less as compared to the spread of this random variable. Okay, so it is basically called the central moment. Okay, the second order central moment, that is how much is the PDF spread around the mean value. That is what is dictated by this equation. And you can further expand it like this. If you defined if you have defined sigma x square as x minus x bar square in, then I can write it as a minus b whole square. It will become x square minus twice of x into x bar plus x bar square, and then the mean of this. And since mean, this is a linear operator, okay, so the sum of means will be equal, the mean of the sum will be equal to sum of the means. So it will be equal to x square bar minus 2x x bar plus x bar square bar. Okay, and that becomes x square bar, which is basically the mean square value of the signal, minus 2 times. Now see, x bar is basically a constant, okay, because it is already the mean value. and the mean of this random variable is going to be constant. And if it, so I can take this outside. So 2x bar into x bar. This is just the mean of this random variable now x. Plus this will become x bar square, because x bar is already a constant, and x bar square of course is also a constant, and the mean of it will be the same constant. Okay, the mean of the constant is same, so it will become 2x bar square, and ultimately becomes x square bar minus x bar square. Okay, so you can say the variance of the random variable can be taken as sigma x square, as you can write it as e of x square, which is the mean square value, or you can write this minus square of the mean, that is ex square. Okay. The variance of x is equal to the mean square value minus square of the mean. And if you have a random variable with zero mean value, then definitely your variance is same as the mean square value of the signal. Okay. So for zero mean random variable, variance and mean square value, they are one and the same thing. Okay. Later on, when we will discuss the power spectral density, you will see that the mean square value also gives you the average power in the signal. Okay, so variance somehow also defines the average power of the signal, that we will discuss later on when we will discuss the random process.